Good morning, y'all. So once again, I'm still here at the farm. We're going to be doing our first video. Now, this is just kind of a review video for Chapter 4 for those of you in class. If you're not in class, this will be something new to you. Hopefully, you'll learn a little something. But then, like I said, this is Chapter 4. This is work, power, horsepower, and torque. So let's just go ahead and get on into it. Three fundamental units that are used for the study of machinery are force, distance, and time. Force is an action that causes or tends to cause motion or a change in motion of an object. So we're getting a little bit of physics here. Like I said, we're not going to go too deep, I promise. I'm not a physicist. I'm just an overeducated farmer. So to describe these forces, three factors must be known. One, the direction of the action. So which way we're pushing this thing. Two, the magnitude of the force, how hard we're pushing this thing. And three, the point of application. So that we're going to be using those, keep those three things in mind. Common units of force include, can be ounces, pounds, tons, kilograms. Now for this class, we're mostly going to be sticking to pounds. We might have some ounces in there. We're not going to be doing a whole lot of metric system things, so we won't go use a lot of kilograms, things like that. Like I said, I'm trying to teach you the concepts, not check your understanding of the metric system. Common units, the distance either displaced, a distance can either be displaced or a length, and it may or may not imply movement. So just kind of keep that in mind. Whether this thing is moving or not, it can still be useful to us, just depending on how we use it. And we'll go a little bit deeper into that in a few minutes. Displacement is defined as an object, defined as a distance an object is moved. So if I take this block right here and I move it 10 feet, I've moved it 10 feet. 10 feet will be our distance. Common units will be feet, inches, yards, miles, kilometers, meters. It can be furlongs, miles, any of those kind of things. Once again, for this class, we're pretty much going to be using our standard measurements, feet, inches, miles, things like that. Time is an interval of duration or the accounting technique used to relate the occurrence of events. So we all know what time is. There's no metric or standard. It's seconds, minutes, hours, days, months, weeks, blah, blah, blah. All those things. We all know what that is. So for that, let's go ahead and get into our first equation. Our first equation is going to be the equation for work, which is defined as W equals D times F. I know I got some glare on the board, so deal with me here. Work, power, horsepower, and torque. But here's our first equation. W equals D times F. Now, those of you in my class, this brings up a very, very important point. You know that my handwriting is garbage. I do my best, but it's still not that good. So those of you in my class, you know this. I'll try to work a little slower, try to reiterate these things so that you know what that hieroglyph actually means. For those of you not in my class, you'll see what I'm talking about. It's really, really bad. So for this, let's plug in this equation. Let's solve for work. So we're going to say W is our variable. Work equals, let's see if I can line this up. Work equals, what is our distance? We'll just pull something out of the air. 1,000 feet times our force. What is our force? Let's just make something up. Say 500 pounds. Pretty simple math here. So what's 1,000 times 500? W equals 5 and 5 zeros. Or 5. Put that in the wrong place. Work equals 500,000. Now what unit is this? Well, it's really simple. You just put it together. So this is going to be foot dash pounds. 500,000 foot-pounds. Now this brings us to another important point. This equation is written in such a way so that we know the distance always comes first. So it's distance times force, not force times distance. Would the math work out the same? Absolutely. But we do this for the very specific reason, so that when we get to our units, what unit we're talking about here it's going to be in foot-pounds. And that's very important in the later on in this lesson when we talk about torque, because torque is the exact opposite. It is pound-feet. So that's pretty simple, right? So let's give an applicable example of this. I'm going to walk over here. This is a 1983 Ford 4610, wonderful tractor, beautiful piece of machinery. This is probably our most used tractor on the farm. As you can see right now, it just happens to be hooked up to a grader blade. Hopefully most of you probably know what a grader blade is, or you can look at it and kind of tell how it works. Basically, you'd use it to level off a road, drag some gravel out. With all this rain lately, we've used this some. We've had some gravel roads wash out, and we'll get out there, and yes, wash with an R. So we'll get out there and we'll regrade the gravel driveway. Very simple machine. We hook it to the tractor and we pull it around. So let's just take an example. We have a driveway that is, I don't know, it's a half-mile long, and we're going to pull this machine and it's going to scrape the gravel. And if we could somehow put a weight, say right here, or a scale right here, and figure out how much we're pushing, we're going to say that it's going to pull, I don't know, 1,000 pounds. Just pulling a number out of my head. So let me erase this. Oh, got to give a big shout out to Miss Becky Morgan, who is the ag teacher at Gallatin High School. With all this craziness going on, it's been kind of hard to find teaching supplies. I guess every homeschool parent, newly homeschool parent, has gone out and they have tried to, but they bought up all the markers and the whiteboards, but she let me borrow hers, so I want to say thank you to Miss Morgan for that. So let's get right into this. How much work does it take to grade that driveway? So work equals our distance, which is 1/4 mile, times our force of 1,000 pounds. Okay, pretty straightforward. Tell you what, we can even make this a little easier for those of you that don't like fractions. We'll call this 0.25 miles. So 0.25 times 1,000, work equals 250 watts. Well, we go back to this, distance times force. So when we go and put the dash in here, what's our distance units? They're miles. What is our force? That's pounds. So to do this, it takes 250 mile pounds. Now, what the heck is a mile pound? Well, that's one of those, we can convert this back and forth. So let me see if I can get my calculator pulled up.